Hello students, welcome back. In the last video class, we had discussed about the context-free grammar and its basics. Context-free language is accepted by one of the automata called as a push-down automata. The context-free language is made up of on a context-free grammar. When I say the grammar is written by using the rules. Sometimes those are called as a production also. To write the rules, we are going to use arrow mark. So this arrow mark, it divides the rule into two parts, as we discussed, left side and the right side. So as we discussed in the regular grammar, what you are going to define at the left of the rule, you are going to define non-terminals at the left side of the rule. And what comes at the right side of the rule? Right side may contain epsilon, a single terminal symbol, or a one terminal followed by one non-terminal according to regular grammar. The context-free grammar is same as a regular grammar, but it is free from the context. That's why the name given context-free. Means what? There is no restriction to write anything at the right side of the rule. So left side, there should be only one non-terminal in a context-free grammar. Right side, you may write a epsilon, you may write a single terminal, next terminal followed by a non-terminal, or you can write a two non-terminals, or you can write non-terminal embedded between the terminal symbol. So all these are valid in a context-free grammar, where such productions are not valid in a regular grammar. Only this much is the difference between context-free grammar and the regular grammar. So we had discussed in the last class the formal definition of the context-free grammar. What is that? The context-free grammar is defined on a four tuples, that is V, T, summation, R, S. So T will not come. V summation R, S. What is a V here? V is a set of the non-terminals which comes in a production, and these non-terminals are written at the left side, or you can describe for this non-terminal, you can describe the terminal symbol or a non-terminal symbol. What do you mean by terminal and non-terminal symbol here? The non-terminal symbols are the rule symbols. They will not contribute anything in the formation of the strings, whereas the terminal symbols are used to form the strings. So usually the terminal symbols are written in a small case and non-terminal symbols are written in a capital letters. So this non-terminal V can define a terminal symbol as well as the non-terminal symbol. What is the summation here? Summation is nothing but a set of the terminal symbol. It is again a subset of a V here. What is the R? R is nothing but a rule. And to write the rule, what all things you keep in mind? See, left side you are going to write a single non-terminal. Right side you may write a epsilon, single terminal followed by a non-terminal. You can write a two non-terminal, or you can embed a non-terminal between the terminals. So all these are okay with the context-free grammar. What is the S here? S is the start symbol, which is again a subset of a P here. The first symbol of the grammar is called as a start symbol. Next, we will see how to write a grammar for a given regular language. The first language given here is the alphabet equal to C, small c. So alphabet set contains a small c here. And what is the given language here? C raised to n, where n is greater than or equal to 0. So you are creating the strings by considering a non-terminal C, and the occurrence of C is what? It is in terms of n, and what is the value of n here? N is greater than or equal to 0. Means the C may occur 0 or any number of time in the language. So what is the first step? First we are going to define the valid strings in the language. So what are the valid strings? So as it defines 0 or any number of C's, so epsilon will come when I take C raised to 0. When I take n value to 0, what I get? I get an empty string here. Next, you may get a single C, or you may get a 2 C's, 3 C's, 4 C's, and so on, based on the value of n. When you get the 1 C, when n equal to 1. When you get the 2 C's, when n equal to 2. When you get the 3 C's, when n equal to 3, and so on. So these all are the valid strings in the language. So I had written the valid strings. What is the next step? Next step is we should write the grammar for this language. See, as epsilon is a part of the valid strings, so I will declare one non-terminal which is called as a start symbol of the grammar. So you can write any characters from A to Z. So I will write here yes. Yes, it defines what? So here I will write a rule to accept what? Epsilon. So I'll write yes produces epsilon. Next, to accept the 1 C, what I should write? Yes produces C. But when I change the n value to 2, 3, 4, 5, I will get what? The repeated occurrence of the C. To take that repeated C's, I will write C followed by yes. So this rule allow me to take one or any number of C's in the language. Okay. So we will take one example and see whether that is derived by this grammar or no. So I will take this example. So C is the input string. Next, I will use the rules to check whether the string is accepted by this grammar or no. So as usual, I will start with the start symbol. So the derivation. So I will derive yes with what? C. I want to read the first C from the input string. So yes has a 2 production here. Yes produces epsilon. Yes produces C. Yes. So to define this C or to accept this C, what I should derive for this yes? With the epsilon or this. So obviously I am going to use a second rule here. So yes is derived as what? C. Yes. So I read the one C here. Next, after that, one more C I want to accept. So what I should substitute for this yes? See, this C I am going to write as it is. Next, what I should derive for this yes? Again I will derive this by C yes. So I accepted second C. Next, what I should derive for this yes? So this C I am going to write as it is. These are the terminal symbols. So I am not going to derive terminal symbol because the derivation is written for only the non-terminals. So here what I should derive for this yes? Again I will derive it as a CS. So yes can be substituted as CS here. So after that, see I accepted the third C also. Next, what I must substitute for this yes? See, shall I substitute for yes as a CS or a epsilon here? See, I accepted the input string. Okay. Next, no need to derive the C 1 second. So I will write epsilon for this yes. So what I get at the end? I get a string which is equivalent to a input string. So based on that I can say the string is accepted by this grammar. So the grammar for this language is S produces epsilon, S produces CS. So this rule allow me to take one or any number of C's in the language. And this rule at the end I am going to substitute as epsilon is a part of this. So I must define epsilon for this yes. Next, consider the second language here. So what is the second language? What is the alphabet set? Alphabet set contains A and B, and occurrence of A and B is what? 0 or any number of times. So the language given here is A raised to n, B raised to n, where n is greater than or equal to 0. So what do you mean by this? You are accepting any number of A's, any number of B's. Okay, 0 or any number of A's, any number of B's you are accepting. Next, the other condition is A should be followed by B. So what are the valid strings I get? See, here it is greater than or equal to 0. So if I take n equal to 0, what I get? I get epsilon here. Once I take n equal to 1, what I get? A raised to 1, B raised to 1. So I will get what? AB. Next, when I take n equal to 2, A raised to 2, B raised to 2. What I get? AA, BB. Next, when I take n equal to 3, what I get? A raised to 3, B raised to 3. So A should occur 3 times and B should occur 3 times in the language. So if I change the n value, I will get a different strings in the language. So these are the valid strings in the language. So I had defined the valid string. What is the next step? I should write the regular grammar for this. So again I will start with the yes only. Okay, yes produces. What I should write? See, epsilon is there. So first I define the epsilon for this yes. Next I must define what? I must write the rule to accept what? The minimum string, that is AB. So I'll write what? A, then S, then B. If I don't write S, what happened? If I directly write AB, it start accepting only the minimum string that occurred in the list. So yes, it allow me to, yes in between, it allow me to take any number of A's and any number of B's for this yes. Okay, so this is a rule to accept any number of A's, any number of B's here. So repeatedly this rule allow me to take repeatedly any number of A's, any number of B's, and the occurrence of this A and B is what? A should be followed by B here. So we'll take one string, so say it as A, B, B. Okay, derive and check whether it is acceptable by the given grammar or no. So as usual I start with the yes. So derivation start with the start symbol yes. So what is the input string character I must read? So it is A. So what I should substitute for this yes? Whether epsilon or ASB. Obviously I am going to use a second rule here. So according to second rule I can substitute this S by ASB. Okay, so once I derive yes as a ASB, I accepted what? One A and one B from the string. Next, what is the next step? See, there is a one more A I must read. Okay, so to read that again I will use the second rule and I will substitute. See, this A I will write as it is, this B I will write as it is. So this yes is derived as what? A, yes, B according to second rule. So if I derive yes as a ASB, I am able to accept what? Next pair of A and B. Next after that, see, I have a yes, B. Next, what I must substitute for this yes? See, end of my string is occur. So string, I read the whole string. What is the next step? See, at the end there should not be any non-terminal in the derivation. So to nullify this, I can substitute this yes by what? The epsilon. So I'll write what? In the next step by using the rule 1, I can substitute this by epsilon and the remaining thing I will keep as it is. So at the end what I get? B, which is equivalent to a input string. So based on that I can say this grammar will accept what? Any number of A's, any number of B's where A is followed by B. Next we'll check the one more, we'll write the grammar for one more language. See, check out the alphabet set. The alphabet set contains A and B. The occurrence of A and B is 0 or any number of times. So the another condition given in the language is WWR. So here we are taking the reverse of a given input string. Okay. So what are the valid strings here? Valid strings are epsilon. Okay. Next, if I take A for a input string, then the reverse of this what I get? I get A only. Next B I will get B only. Next if it is a AB, what is the reverse of this? BA. Next AAB, so what I get? BAA. So these all are the valid strings in the language. So how to write the rule for this? So I will start with the start symbol. So I will derive S as a epsilon because epsilon is a part of the valid string here. Next, see, if in a string if I accept a 1A, the reverse of that will be A only and that should occur at the end of the string. So W indicate the string and WR is followed by this W. So if I take for W, if I take A, what is the WR here? Again it contain A only. If I take for W, AB, what will be the WR? BA. So W is followed by reverse of that. So for that I will write if I get a for a W, what I get for the reverse of that? Again A. So shall I write yes produces A? Yes, this is a valid rule to accept what? The A's, okay, any number of A's. Next or A or B, yes, B. So if I take for a WB, what I get for a W raised to R, I'll get B again. Next, if it is a BA, then what will be the reverse of that? It is AB only. So I'll write the rule that ASA, BSB. So this is a rule to accept what? The string, the reversal of a given string. Next, we'll take one example and check whether this rule work on that or no. Okay, so I'll take an example AB, BA. So AB is a W, BA is a reverse of that. So I am going to use the grammar symbol for the derivation. So I start with a yes only. So yes produces. What I must substitute for this yes? See, what is the first symbol to read? It is A. So here yes can be substituted as ASA or BSB. According to the input string, I must substitute yes as a ASE. So I will write here ASA. So based on that, I accepted what? The occurrence of A in the string. Next, what I must substitute for this yes? See, what is the next input symbol here? B. So which rule I should take for this yes? So yes has a two rules. One is ASA, another one is BSB. So here, which one I should take? See, I want a B character here. So A and A, I will write these A's as it is. Next, for this yes, I will derive this yes as BSB. So once I derive this, what I get? A, B, yes, B, A. Okay. Next, what I must derive for this yes here in this stage? See, shall I go with the first rule or a second rule? No, I don't require these two rules. So I am going to end this because I accepted the string which is given here. So what I must substitute for this yes? Yes can be substituted as epsilon. So once I substitute epsilon for this, what I get? AB, BA. So which is equivalent to a input string here. So check out for the remaining string. So these are the grammars to accept the language 1, language 2 and language. We will see one more example for this. So here the given language contains the strings. String is nothing but a W here. W is defining a pair of brackets here. The square brackets it is defining, 0 or any number of brackets it is defining. So what are the valid strings in the language? See, as it is a star, so it define what? The epsilon. Next, the bracket, open and close bracket will come. So this is a minimum string it will generate. Next, the nested bracket is also comes under the valid string list, or it can generate the sequence brackets. So these are the some valid strings in the language. Next, we are going to write a context free grammar to accept the pair of the brackets. So here, as it is defining the epsilon, first I will write the grammar symbol, that is yes. Yes defines what? Epsilon. Next, if I want to take a nested brackets or a n number of brackets, then what rule I should write? See, each open bracket has its close bracket. Okay. Next, these brackets may come one or any number of times. If I write this, so this rule allow me to take the sequence of nested brackets. Next, to take a sequence of brackets, so to take a sequence of brackets, I am going to write a one more rule, that is yes produces yes yes. So this rule allow me to take a two sequence brackets. So this is a grammar to accept the pair of brackets. Next, we will take one example and check whether that is acceptable by this grammar or no. So I will take the nested brackets. I want to accept this. So I will start with the yes. So yes is derived by what? Open bracket, yes, the close bracket. Now, based on a rule 2, I had derived yes as a open bracket, yes, close bracket. Next, see, if I derive this, I am able to accept the outer brackets. Next, yes must be derived in such a way that I get a inner bracket. So which rule I am going to use among these three? I am going to use the rule 2 again. So using the rule 2, I will derive this yes as what? Open bracket, yes, close bracket. Next, so after derivation, what I get? I get the inner brackets also. Next, this is the end of the string, but here the yes is left out. So what I must substitute for this S? Epsilon, bracket S or SS. So obviously I am going to substitute this as a epsilon. Once I substitute this as epsilon, what I get at the end? The two brackets. One is a nested, another one is the outer bracket. So this is same as a input string. So based on that I can say the string is accepted by this grammar. Or we can take a sequence of brackets. So to accept this sequence of bracket, I am going to start a derivation with a S only. So S can be substituted as bracket S or SS. If I take a bracket S, I am able to accept only one bracket. But here the sequence of brackets are there. So I will take S produces SS. So based on the third rule, I will derive S as a SS. Next, for this S, what I must substitute? See, the S can be substituted as open bracket to get the first bracket. So based on the rule 2, I will substitute this S as open bracket S, the close brackets, and this S I will write as it is. Next, so I got what? The first bracket I got. Next, if I substitute, I must substitute the first S. So what I must substitute for this S? That is epsilon according to rule 1. So if I substitute epsilon, what I get? The first bracket. Next, what I must substitute for this S now? So based on the rule 2, I will substitute this S as open bracket S, the close bracket. In the next step, I am going to substitute this S as epsilon. So once I substitute this, what I get at the end? The open bracket followed by another bracket. The sequence of brackets I get. So based on these two derivation, I can say this is a grammar to accept the pair of brackets. Next, we will move to the next concept where we are going to discuss designing of the context-free grammar. So designing of the context-free grammar, it contains the simple two ways to define the strings which belongs to two regions, where these regions are correspond or they not correspond with each other. So these strings are defined by using two simple ways. The first way is to generate the strings with multiple regions. So the language contains the strings and strings belongs to multiple regions. That must occur in some order. The strings are occurring in some order but do not have to correspond to each other. They are not dependent on each other. See, we are defining the strings which belongs to multiple regions. They are not correspond to each other but they are in some fixed order. So to define such strings, we are going to write the rule in this way. So check out the right side of the rule. So here I had defined two non-terminal continuously. The first non-terminal, it defined strings for one region. Second non-terminal, it defined the strings for another region. So two region strings are defined by these two non-terminal, but they are not dependent on each other. They are not correspond to each other. So B, it defined the strings belongs to a first region and D define the strings which belongs to a second region. So we can write the rule to define the strings for two region. So we'll take one example. So consider this example. So here the example belongs to the first way to generate the string, where strings are defined in two different regions. So here check out the given language. The language contains alphabet A, B, C. A should be followed by B, B should be followed by C here, and the A raised to N, B raised to N, C raised to M they had given, and the occurrence of this A, B, C is 0 or any number of times. So N comma M greater than or equal to 0. So here based on the power they had given, I will divide these strings in two regions. The first region contains A raised to N, B raised to N, and the second region contains C raised to M. So to define the strings of A raised to N, B raised to N, I will take one non-terminal. I can say it as a B. Next, to define the strings of a second region, I will declare the non-terminal, that is D. So what is the purpose of D in the grammar? It will define the strings belongs to a region A raised to N, B raised to N. And what is the purpose of D in the grammar? It defines the strings belongs to a second region, that is C raised to M. And the occurrence of these is 0 or any number of times. The next step is I am going to write the strings, valid strings which belongs to the language. So what are the valid strings here? So if I take n equal to 0 and m equal to 0, so what I get? I get a epsilon here. Next, if I take n equal to 1 and m equal to 0, what I get? See, a raised to n, b raised to n is there. So I will get what? ab only. Next, if I take n equal to 0 and m equal to 1, what I get? I get only c here. Next, if I take n equal to 2 and m equal to 1, so the occurrence of a and b is what? It is a 2 times. So a raised to 2, b raised to 2, which is followed by 1c. So a, b, b, c I get. Next, if I take n equal to 3 and m equal to 2, then what all strings I get? I get a raised to 3, b raised to 3 and c raised to 2. So these are the some valid strings in the language. So I had defined the valid string. What is the next step? I must define the rule for this. Okay. So check out a raised to n, b raised to n. It is same as a language 2. So a raised to n, b raised to n is greater than or equal to 0. So what are rules I had written for this? So the rules accept what? Any number of a's and b's. So same rules I am going to write here for this b. So before that I must take a start symbol here. Start symbol derives what? The two non-terminals according to this, because here I am defining the strings of a two regions and those regions are derived by a start symbol here. Okay. Next I must write the derivation for this b. So b, it will define the strings of what? A raised to n, b raised to n, where n is greater than or equal to 0. So any number of a's, any number of b's get accepted by this b. So it is same as a language 2. So based on that I can write b produces epsilon. Next b produces what? A, b, b. Next I must define the rules for a second region. It is nothing but any number of c's get accepted by this, the non-terminal which is defined for a second region. So this is same as what? The language 1, where c raised to n is greater than or equal to 0. So what all rules I had discussed with you in the previous section. So based on that I can write d derives what? D derives epsilon or d derives small c and d. So first region, that is b, it is defining any number of a's and b's, where a is followed by b. Next d defining the any number of c here. So this is a combination of a two region strings. So here based on the first method, okay, so I had defined the strings which belongs to a two different region. Next we will take one example and check whether this rule or a grammar work for these valid strings or no. So I will take a, b, b and c. This is the input string I want to derive. So obviously I am going to start with a yes only. So yes derives what? Which one I should take? Yes derives. There is only one production, so I must use that. Yes derives bd. Next, what I must derive for this b? It should accept what? The first input character. So b's, it has a two production. Which one I am going to consider? I am going to consider the third production. So this is first, this is second, this is third, this is fourth and this is the fifth production. Based on the third production, I will define this b as what? A, b, b and this d I will write as it is. So if I derive this, I am able to accept out 1a and 1a and 1b. Next, again I must derive this b. Okay. So what I should write for this b? This small a and b I will write as it is. Next, again I am going to derive this b as a, b, b. Okay. If I do that, I am able to accept out another pair of a, b here. So this d I will write as it is. In the third iteration, I must derive epsilon for this b. So according to the rule 2, I will derive epsilon for this b. So after deriving, what I get? A, b, b and d I get. Next, so I am able to accept what? A, B, B. Next input string that I must accept is C, small c. To accept that, what I must derive for this C, derive for this D. D has a two production here. One is a epsilon, one is a CD. So according to the production 5, I will derive this D as CD. Next, what I must derive for this D? See, check out the input string. So here input string is over. I reached at the end of the input string. So what I must derive for this non-terminal D? So whether I derive it as a CD or a epsilon. So it is the end of the string. So I am going to finish this. So finishing is done by substituting the epsilon for this D. So after substituting by epsilon, what I get? A, B, B, C. So this is a rule to accept the strings of two regions. We will take one more example for this. Next example, check out the language given here. It is A raised to I, B raised to J, C raised to K. So what is the J value here? J equal to I plus K, where I, K is greater than or equal to 0. So I will elaborate this. So it is nothing but A raised to I, B raised to J. What is the J value here? J is nothing but I plus K, and C raised to K is there. Next, so once I elaborate this, what I get? A raised to I, B raised to I, next B raised to K, and C raised to K. Next, see, what is the power of these two? It is I, and what is the power of next two? It is K. So based on the power, I will divide these strings into two regions. And to define these two regions of a string, I will declare two non-terminal. So B is defining the strings where A is followed by B in the ith time, and I will declare one more non-terminal, that is D. It contains what? The B followed by a C with a K times. So based on that, I will write the rule. So S produces what? BD. So S is the start symbol here. B is a symbol which defines the strings of a first region. D is a symbol which defines the strings of a second region. And the strings I and K value is greater than or equal to 0. So epsilon is a part of the valid string list. So B, so what B define here? B define A, any number of A's followed by any number of B's. So based on that, shall I write A, B, B. So this is same as what? The language L2. Next, or B define the epsilon. Next, what D define here? D define the strings where B is followed by C. So B is followed by C. So this rule allow me to take what? Any number of B's followed by any number of C, or D define what? Epsilon. So this is a grammar to accept the strings which belongs to a two regions. So here I started with the grammar symbol S. So this S symbol contains a non-terminals which are defining the strings of a two regions. So B is defining the string where A is followed by B, and D is defining the string where B is followed by C. So any number of times these may occur, or it also produces the epsilon because the I and K, the occurrence of this is greater than or equal to 0. So we will take one example and see. So here I will take A, B, 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 C. So this is a valid string. So to accept this string, I must start with a S. S is derived by BD. Next, this B is derived by what? To get the first pair of AB. So I will derive this as AB, B. This D I will write as it is. Next, this A I will write as it is. Again I will derive this by B is derived by A, B, B to get the next pair of AB. Okay. After that, so according to the rule number 2, this is also according to the rule number 2. Next, according to the rule number 5, I will derive epsilon for this, and this D I will keep as it is. So A, B, B. Next, I must derive what? The BC for this D. So D is derived by what? D is derived by using the rule number 4. So using the rule number 4, I will write B, D, C. Next, what I must derive for this D in the next iteration? It is derived as epsilon. So once I derive this as epsilon, what I get? A, B, C. So which is same as a input string. So it will accept all the valid strings belongs to this language. Next, the another type of generating the strings which are belongs to two regions again. See, this is a method to generate a strings with the two regions that must occur in some fixed order and that must correspond to each other, dependent on each other. So in such cases, we start at the outer edge of the string and generates towards the middle. So to generate such string, we are going to divide the regions in two parts, outer region and the inner region. First, we are going to define the strings for the outer region. Then we move towards the strings of a inner region. So we will check an example for this. So the rules look like this. S produces A, S, B. So it defining the strings of the outer region. Then the S can be substituted as B, where B define the strings of a inner region. So check out the difference between these two. Here they are not correspond to each other. So whatever the non-terminal you have defined to accept the strings, they are not correspond. Here they are correspond. They are occurring in a fixed order, and such cases you are going to define, you are going to declare a non-terminal to accept the strings of the outer region. Then you are going to define the strings for a inner region. We will take one example for this and check out. Consider an example for a second way of defining the strings for different regions which are correspond to each other. They occurred in some fixed order. Okay, so here we are defining the strings for a outer region. Then we are moving towards the strings which are in the middle region. So we will take one example and see how to write a rule for such languages. So here the given language is A raised to I, B raised to I, C raised to K. So A, B, C are define a string in the language where I equal to K plus J. So I will occur K plus jth time, and the occurrence of I and K is greater than or equal to 0 here. So I will elaborate this first. So it is nothing but A raised to I. So I value is what? K plus J. So I will write K plus J here. Next B raised to J and C raised to K. So after elaborating this, shall I write A raised to K, A raised to J, B raised to J and C raised to K. Okay. So check out the occurrence of the string in the language. Okay. See the string which are at the outer edge are same, their power are same. So A is occurring K time and C is occurring K time, and the strings which are in the middle, the occurrence of that is same, that is they are occurring at a jth time here. Okay. So here, so based on that I will define the rule to accept the strings which are at the outer edge. So say it has a B. So B defines the strings of outer edge, and D defines the strings of a inner or a middle part of the string. Okay. So what are the valid strings? So valid strings are A, B, C is a minimum string that you are going to accept. Epsilon is there. So write down the valid string first. So after writing the valid strings, so I will write this rule here. So I will take a start symbol S. So S defines what? S defines first the outer strings are defined. Okay. So outer strings contain what? The K number of A's and K number of A's followed by a K number of C's. So it is same as the rule 2. Okay. So instead of A raised to N, I have a raised to K, B raised to, instead of B raised to N, I have a C raised to N. So it is same as the language 2. So based on that I can write A, then S, then I write what? C here. So this rule allow me to take any number of A's followed by any number of C's. Next, so this S is defined by what? the variable which define the middle part of the string. So S can be A, S, C, or S may have what? S may have a D. So based on that, based on these two rules, see, either I should substitute S as a S, C. Okay, so if I substitute, I get the characters which occur at the outer edge of the string. Next, this S can be substituted as D, where D define the strings which comes in the middle part of the string. So what I must write for this D? D defines what? A is followed by B n number of times. So based on the rule 2, shall I write A, D, B or epsilon? A, D, B or epsilon. So here A, S, C allow me to take the strings which are at the outer edge, where D allow me to the strings which comes in the middle part of the string. So this is the example for a second way of defining the string. So we will take one example and see. So here I will write A, where K value is 2. So A will occur 2 times, C will occur 2 times, and J value is 1. So this AB occur 1 time. So this is a valid string in the list. So I try to derive this by using this grammar. So here first I start with the S. So what is the first character in the input string list? That is A. So that can be accepted by substituting or by deriving S with the ASC. So I will derive ASC. So after deriving, I am able to accept the outer edge character of the string, that is A and C. One pair of A and C. Next, again I am going to define this S by ASC, because the next input string character is A again. So this A I will write as it is, this C I will write as it is. This S can be substituted as what? A, S, C. So after substituting, I am able to accept the pair of AC which are at the outer edge. Next, I am going to define this S by what? So S can be defined as ASC. No, it is not required, because next input symbol is A here. So here A and B I want to accept. So S can be defined by a second rule, that is S produces D. So I will write S produces D, and the remaining thing as it is AADCC. Next, this D can be defined by what? The rule number 3, that is AAADB, and this C I will write as it is. Next, at the next iteration, using the D produces epsilon rule, I will substitute epsilon for this D, and the remaining thing I will write as it is. So at the end what I get? AAABCC. So AAABCC, which is same as a input string. So the valid strings, all valid strings belongs to this language, get accepted by this grammar. Next we'll take one more example on this. Second example here. The second example where the language defines A raised to n, B raised to m, where n is not equal to m. So the occurrence of A and B is n and n number of times, where n, the occurrence of A is not equal to the occurrence of B. So here n is not equal to m indicate what? The n should be, there are two ways, the n should be greater than m, or m should be greater than n here. Okay, then only those A and B, the occurrence of A and B is not equal to each other. So here the two ways we are going to consider. So n is not equal to m, it indicate what? N value should be greater than m, or m value should be greater than n. See, first we are going to take n and m equal number of times, then we will increase n by 1 or 0 number of n's. Okay, so first we will make these two as equal, then we will take n value greater. Here first we will make m and n equal, then we are going to take m value greater. So to write the rules for this, so first we start with the S. S produces A or B. So A is defining a rule where we are considering a n is equal to m and n value is greater than n. Okay, greater than n. So here, so to define that, S produces A and B, where A is for this, A defining the strings for a first region and B is defining the strings for a second region. So according to this, first we'll define a equal number of A's and B's. So this rule, it will allow me to take equal number of A's and B pair. Okay, n number of times I can take by repeating this rule. Or see, here n value should be greater than 1. At least one A should be greater. So one A should be greater means at least one A must greater than a B, because n define what? A. So here greater than n means at least one extra A should be occur in the language, or any number of A's. Any number of A's can be defined by this rule. This rule allow me to take any number of A's. This rule, so actually A is defining the three rule. The first one, it will allow me to take a equal number of A's and B's. So at least one A should be greater, because n value is greater than m. So n is defining the A. So at least one A should be greater. So that is defined by a third rule. What is the second rule? It defines any number of A's. So A's are greater one or any number of A's, that is defined by a middle part of the rule. Next, the B defines what? B defines B A B, B A A. So n number of A's, n number of B's will come. Next, at least one B should be greater, or any number of B's should occur in the language. So this is a rule which accept the strings of A's and B's, where the occurrence of A is not equal to the occurrence of B. So we'll take one example. So here the input string is AAB. Check out, the occurrence of A is 2 and the occurrence of B is 1 here. So we'll apply this rule. So first I start with the S. S derives. So I want to accept the A, and A is defined by what? A is defined by grammar symbol A. So I will substitute this S by A. Next, A define what? A B. Next, this A define what? According to this rule, A B. So this is same as a input string. So it start accepting the n value greater than m value. Next, we'll take the another example, that is BBA. So for this, S can be substituted as, see, what is the first symbol I want to read here? B, and that is defined by what? B here. So S is substituted by B. Next, B is substituted by B. So here I should write B here. So B. Next, this B can be substituted as what? See, I want one more B. So B can be substituted by considering this rule, B produces small b. I will write B for this capital B, and this A I will write as it is. So it accepts what? B A, so which is same as a input string. So the string may start with the A or it may start with the B. If it start with the A, either A value should be greater than B or B value should be greater than A. So this is the grammar which accept that. I hope you understood these two methods. These are the very simple methods which are used to design the context free grammar.